Hi folks, welcome back to Physics with Captain Rod. I'm making this video here to help you out with numbers 9 and 10 in your Unit 4 homework. So number 9 says something about find the electric field to the left of the middle charge. They're talking about this one. So that's a point like about here. Now these distances are all given in the problem, like from here to here and from here to here. And then of course from here to here would be half of that. Here to here again, half of this as well. So I'm going to assume you can find those distances. Now, we just got to go through and draw all the electric field vectors. So the electric field vector here due to charge 1 is to the right. I'm going to call that one like E1. And then E1 in magnitude is K times Q1 over, I'll put like D1 squared, where that would be your D1. Okay, now charge 2. The electric field at this location due to charge 2 would be to the left. And that one is going to equal K times charge 2 over, I'm going to put D2 squared. That's D2 is this distance. And then charge 3. The electric field due to charge 3 is also to the right, right? Because the electric fields point towards negative charges. And that that electric field is going to be K times charge 3 over this distance squared. I'll put D3 squared. So what you need is you need to calculate these numbers here, here, and here. And these are numbers that have units of newtons per coulomb. And then you're going to add them, but they have to be added like vectors. So these two are positive, and then that one's to the left, so it's going to be negative. And you'll get some number, again, with units of newtons per coulomb. And one thing I'd like to point out, there's not going to be any questions on your quiz where you're having to do calculations like this. Oops. Let's get rid of that. There we go. So you don't need to worry about that. There could be questions about finding the electric field directions, however. So that definitely could be on your quiz. Okay, now, number 10. There's an electric field, and I can't remember the field strength. I think it might have been like 275 newtons per coulomb. Yours is probably different because I set these to be kind of random. And I just put it to the right in my picture. Now, if we put an electron in that field, the force direction on the electron would be to the left, right? Because remember, the electric field direction is based on the direction of a positive test charge, meaning if I put a positive test charge here, the force will be to the right in the same direction as the field, but electrons always do the opposite. Now, you can calculate this force from the charge of an electron, which is 1.6 times 10 to the minus 19th coulombs, times the electric field given in the problem. This is going to be a very, very small number. It'll be like probably times 10 to the minus 17th or so newtons. So that's step A, or part A. Part B is to find the time, so we're going to draw a velocity graph. So velocity against time. Remember, way back from the first unit. So at t equals 0, the electron not moving yet. Sometime later that we don't know, it's going to be moving at some, I'll call it V final here. And we don't know that either. So bear with me. And then we're going to assume constant acceleration, which makes that graph linear. So there's two important equations we can get from this graph. One, the acceleration is equal to the slope. And that's V final over T. Rise over run. And then second, the distance traveled, and I think that was probably given in the problem, is equal to this area here. 1/2 T times V final. So this problem requires a little bit of algebra. You're going to want to solve this one for V final, and you're going to get whatever the acceleration times time is. Oh, then the question is, how do we get that? You get that from Newton's second law. I forgot to mention that. Right? Once you have the force from part A, you just set that equal to mass times acceleration to get the acceleration. Getting back to the graph, so the acceleration is the rate that velocity changes. It's going to be the slope, V final over T. the area here is going to give us the distance traveled. You have to kind of combine these two equations to solve for time. So that should get you through these two problems. I hope that helps. These are two of the tougher problems on here, particularly this one. Don't worry, you're not going to have to do things like that on the quiz. However, drawing the field directions is definitely something that would be conceivably on that quiz. So anyway, I'm going to make sure you get a practice quiz before you do take that thing. Have a great day.